In the last class, we have seen the refraction of light through a glass prism. In this class, we are going to look at the factors that are affecting the angle of deviation. We have found out the angle of deviation is an important parameter that comes out of the analysis. In case if you have not seen, I suggest that you watch that video first and then watch this. So the angle of deviation is an important parameter, and we need to know what are the factors that affect the angle of deviation. It is not only important from the point of your examination, but also it is important from the practical point, because whenever we want to make optical instruments, we need to control this angle of deviation, and then controlling of the angle of deviation is possible only when we know what are the factors that are affecting it. So let's look into the parameters. The first parameter that will affect the angle of deviation of the delta is angle of incidence. So if we plot angle of incidence versus the angle of deviation, so take a prism and then keep changing the angle at which we will incident, and then we will see what is the amount of deviation at each time, then we will get a graph like U. So which shows that as I is increasing, initially the delta decreases and reaches a minimum. But beyond a particular angle, and then again it rises. So that means there is a one particular angle at which the amount of deviation will be minimum. So if we see the equation from the prism, we know that I1 plus I2 is equal to A plus delta. So if the angle of prism, that is A, is already fixed, so we cannot change it. But angle of incidence and angle of emergence we can control. Our angle of incidence we can definitely control. For example, if angle of incidence and angle of emergence are equal, so then that is when the delta will be minimum. Because to keep the delta, to make the delta minimum from this equation, if I see my delta is equal to I1 plus I2 minus A. If I want to minimize this delta, I cannot change that, because that is constant. I cannot change the angle of prism. What I can change is these two I can change. So if any number is a sum of two numbers, when will that number be minimum? Only when both of them are equal. That is the condition that we all know. For example, if I have, let's say, when these two numbers are there, the summation of these two numbers will be minimum only when both of them are equal. So when I1 is equal to I2, that is when your delta will be minimum. So I1 is equal to I2, or I call it that because both of them are same, I will call that as I. So that is when I will realize the minimum deviation in the incident ray to the emergent ray. So that minimum deviation is given by when I substitute I. So that is equal to I1 is equal to I, I2 is also I, so that is 2I minus A. So the value of the delta minimum will be given by 2 times I minus A. So this is possible physically only when your triangle is either a equilateral triangle or it is an isosceles triangle. So whenever so equilateral triangle, or in case of an isosceles triangle, that is when it is possible to have in any triangle actually it is possible. It does not necessarily be equilateral triangle or isosceles triangle. For any triangle we will definitely have a delta minimum. So it does not matter whether it is an equilateral triangle or isosceles triangle. For any triangle it is possible to have delta min, that is possible when my I, that is I1 is equal to I2 is equal to I. The other factor which will affect the angle of deviation is the mu, that is refractive index. That means if my refractive index is more, then my delta is more. The other factor is angle of the prism. If the angle of the prism is more, then my angle of deviation is also more. And then wavelength, let's come to wavelength. If my wavelength is more, I know that my mu is less. Because I said that red wavelength, that is red light, as soon as the wavelength is more, then we know that more wavelength will not bend much. So that is mu is less. When the mu is less, delta will be less, because we know mu and delta are directly proportional. So mu is less and delta is less. What about the color? Let's take the violet color. But for violet color, I know the lambda is small. And then if the lambda is small, then my mu will be more. If my mu is more, then my delta is also more. It's not less, it is more. If mu is more, and then my delta is also more. Come to the red light. So for red light, my lambda is more. If my lambda is more, mu is less. If the mu is less, my delta is also less. So these are the factors that affect the angle of deviation in a prism, and do not get confused between these factors and the factors that are there in a rectangular glass slab. The only difference is their angle of incidence and also the delta are directly proportional, but here it is not. So there will be a delta thing. Apart from that, everything else is exactly similar to that. So in the next video we are going to go to the new topic.